Hello students, welcome to Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now let's solve this problem. In this problem it is said that the conveyor belt is moving downward at 4 meters per second. If the coefficient of static friction between the conveyor and the 15 kg package B is 0.8, so we have to determine the shortest time the belt can stop so that the package does not slide on the belt. So as we can see that this package B is moving downwards with the conveyor belt, and this conveyor belt is inclined with an angle of 30 degrees with the horizontal, right? So if we consider that package B, so we will have the friction force which will be acting in the upward direction. That friction force will keep it stationary, right, since it's the static friction. And here we will have that normal force which will be acting on this package B, right? So let's say this is that normal force. So the friction force will be equal to 0.8 times that normal force of the surface. And similarly, the weight of this package will be acting vertically downward, right? So this will be the weight, and its mass is 15 kg. So this will be 15 times 9.81. and now if we extend the line of action of this normal force, right, so if the conveyor belt is making 30 degrees with the horizontal, then this weight is going to make 30 degree angle with the normal, right? We have discussed this, right, many times we have discussed this, that how this weight is going to make 30 degree angle with the normal, right, if the incline is making 30 degrees with the horizontal, right? So now we can resolve this weight into its components, right? So if I resolve this weight into its components, so it will have two components. We will have one component, this one will be the cost component, and similarly it will have one another component like this. So this one is the cost component. We can write that this is 15 into 9.81 cos of 30 degrees, and this one is 15 into 9.81 sine of 30 degrees. And let's assume that this is our positive x direction and this is our positive y direction, right? So this is our positive x and this is our positive y direction. Up the incline is positive. So now if we apply the summation of forces along y equals to MAY, and as we know that since the package is only moving along the incline, it is not accelerating along the y-axis, so this means that the acceleration along y is 0. So this means that the summation of forces along y is equal to 0. So now as we can see that this n is acting along the positive y-axis, so I have to write plus n minus this cos component which is acting in the negative y direction. So this is 15 into 9.81 cos of 30 degrees, and this will be equal to 0 since the acceleration in the y direction is 0. So from this we can say that the normal force is equal to the cost component of the weight, right? So the cost component of the weight is 15 into 9.81 cos of 30 degrees. So this gives me 127.44 newtons, right? So n is equal to 127.44 newtons. Now if we apply the summation of forces along x equals to MAX, right? So now as we can see that this friction force is acting in the positive x direction, so I have to write plus 0.8 times n, and now we know this n, which is 127.44, and this sine component is acting in the negative x direction, so I have to write minus 15 into 9.81 sine of 30 degrees, and this will be equal to MAX. So the mass of the package is 15 kg, so 15 into AX, right? So if I divide both sides of the equation by 15, so we will get that acceleration of this package B. So this is 0.8 into 127.44 minus 15 into 9.81 sine of 30 degrees divided by 15. So the acceleration is 1.892, let's say. This is meter per second square, and this acceleration, since this acceleration is positive, so this means that the direction of the acceleration is in the positive x direction, like this. So this is that ax, right? So it is in the positive x direction. Now, as we know that the velocity, initially the package is moving with initial velocity of 4 meter per second, and now we know the acceleration ax, which is 1.892, and since it is required to, we are required to determine the shortest time the belt can stop, right? So the final velocity of the belt need to be 0 meter per second. So then we are required to find the time. So we can apply the equation of kinematics, right? So we can say that V is equal to V naught plus AXT, right? And since the velocity is, this 4 meter per second velocity is in the negative x direction, right? So we have to put this velocity as negative, right? This is 0, right? So this velocity is 0. This is minus 4. This is minus 4 in our positive x direction, right? And AX is 1.892 T. Or from this, if I bring this 4 to the other side of equation, so it will become positive. So we will have the equation like this, and T will be equal to 4 divided by the acceleration, 4 divided by 1.892. So this is 2.11 seconds. 2.11 seconds. So the conveyor belt need to stop in 2.11 second if we want the package to stop, and if we want to avoid this package to slide down the incline, right? So this is the solution of this particular problem. I hope you people would have understood this problem solution. Kindly subscribe my channel if you haven't subscribed it yet. Also like this video if you people want me to solve such more problems.